Okay, welcome everybody. My name is Kevin. I'm the training coordinator with the Association of State Floodplain Managers, and I'd like to welcome you to our presentation today. We're going to be talking about flood inundation mapping services from NWS. We've got a great topic lined up, really good talk and really great speakers to share some knowledge with us. But before we get into the topic at hand, I just want to go through a few admin announcements and kind of set some expectations for the day today. So, excuse me. First thing I just want to let everybody know is, we've got a pretty big audience here on this presentation today. So all of your lines are automatically muted. I know it can be a little bit frustrating for engagement and participation that way, but we do have a chat panel if you have, some comments or things you want to share. We also are going to do a dedicated question and answer period at the end, at the conclusion of the presentation. So if you have questions about anything you see today, please find the Q&A area of the Zoom interface here. There, like I said, there is that chat, but sometimes questions get lost. So find the Q&A area and drop your question in there if you want the presenters to weigh in on those. And like I said, we'll hold those until the end, but please use that Q&A window if you would like. This is approved for continuing education credits for floodplain certified floodplain managers and also continuing maintenance credit for AICPs. So I'll send out reminders and instructions for getting credit for both of those certifications. But national level CFMs, you'll likely be getting credit automatically, and that'll be updated in your CFM records in about a week or so. And also, we're recording this, and it'll be available on ASFPM's YouTube channel. So if you miss something, or we're moving too fast or whatever, it'll be available for reference later on. And again, that's something I'll send an email to you about in about a week. So, um, you know, some of you may be familiar with this webinar series we do. It's a quarterly webinar. We're always looking for topics. So if you're interested in suggesting something, you see Alan Luloff and his contact details at the top of the slide here. Go ahead and email Alan and suggest something if you'd like to see it in this webinar series in the future. So with that, I am going to turn things over to Alan. Alan Luloff is in our Flood Science Center here at ASFPM. So Alan, if you wouldn't mind telling us a little bit more about the CTP subcommittee and their work and our topic and speakers.
Yeah, hello. The ASFPM passed a resolution in support of the CTP program about in 2014, and we've created a subcommittee that focuses on the Cooperating Technical Partner Program. And the co-chairs, you can see here, are Joanna Rolfe with the state of Kansas and Manuel Razo with the state of Texas. And you can see the goals here. And one of the major goals we have is to provide training. And we do quarterly webinars, of which today we're doing one. And but you can also see that we also provide general support for the CT across the country. And especially when the situation we're running in now is a little bit of a challenge, we're trying to provide that support to the CTPs across the country. So you can see today's presentation is on National Weather Service Flood Inundation Mapping Program. And we have two speakers today. Derek Giardino, he's the floodplain mapping program, the Geologist Divisions at the Office of Water Prediction. He has a degree in meteorology, and he's currently residing and working out of Fort Worth, Texas. And then we also have Jeff Dober, who is a senior hydrologist with the Science, Innovation, and Partnership Division at the Office of Water Prediction. He spent most of his career in the field operations in the Southeast River Forecast Center, and he's basically works out of. He has a degree from Ohio State University in atmospheric science. So with that, I'll turn it over to our speakers. And by the way, I hope I didn't massacre your pronouncing your names too badly.
Appreciate the introduction, Alan. My name is Derek Giardino. That's a lot simpler than you made it sound. I should probably spell it a little simpler, but in Italian it means garden. But today I'm here to talk to you about flood inundation mapping services and what the Weather Service is doing towards getting everyone that I see listed as I'm looking the comments come in from all across the country. We'll talk a little bit about our rollout plan. Right now, we're out for about 60% of the country, but by this time next year, I'm hoping everyone with their name in that side channel will have flood inundation maps available to them. So Jeff, you're driving, so you can go to the next slide. I'm going to talk about today is the projects that do make up the FIM development program, so you kind of understand where we develop, and then I'll talk about the steps that we take to generate FIM. And then I'll go over a little bit about how we've evolved from our initial FIM versions to where we are today. And then I'm going to give you also a glimpse into what we're working on here for the near future, so you guys have a full idea of how and where our development is going. I will tell you on the left there, you can see we have 30 people directly on the project. That's 3 different contractors plus federal employees. Every day we make about a terabyte worth of data. And interestingly enough, if you stack all the code that makes FIM generation, it would be 2 Sears towers on top of each other. Yes, I'm from Chicago, it's still the Sears Tower. And another 500 feet on top of that. So it's a significant amount of code running to generate these mapping for the entire nation. So we'll go to the next slide, Jeff. The 3 projects that make up our FIM development program, first is HydroFabric, and we'll go over each one in a little more detail. HydroFabric is obviously the foundational base data, taking raw DEM, raw LiDAR, and discretizing it so we can use it for modeling. The second part is the flood mapping development. That is taking the HydroFabric and then going ahead and putting water on top of it to generate mapping libraries. These mapping libraries can then be called and to stitch together flood inundation maps. And then our last program is the hydro visualization. Basically, they run our pipelines in the Amazon Web Services to generate our services onto a cloud platform that's open source. So you can grab them and put them into any kind of viewer you're used to, or you can use them and see them on our website, which Jeff will present about in a little bit. So going to the next slide, we'll start with HydroFabric. Well, first we'll talk about the steps to FIM generation, which is obviously we'll develop the HydroFabric, we'll generate the FIM libraries, visualize, and dissemination. So let's start with step 1. Jeff, go next slide. HydroFabric, and I went to school for 7+ years, getting an undergrad and master's degree, all to learn that water flows downhill. I think everyone here knows that we went through a lot of training just to figure out that one small little fact. While that's a simple concept, it's really difficult to model. And that's where HydroFabric really comes in to take a lot of the discretization out of, okay, it flows downhill, but where? And where do we want data from? And where does the flow line exist? All these questions are really key that HydroFabric answers. And I think it's the toughest part of the entire process. Currently, we use USGS 3-depth DEM as a base. We also use the NHD Plus for our flow line information. That's for FIM. But we also make an in-house HydroFabric that kind of bends and twists a way we can utilize it to best for our national water model. You can go to the next slide, Jeff. So to give you kind of a basic, this is a basic model. You can see those red stars are basically where we would like a hydrograph, right? You want to know the flow at those points. But you can see the flow lines and the catchments all don't match up with where exactly we have points of interest. So we have to figure out how to lump sum and aggregate rainfall that falls over these areas into these flow lines and get a flow measurement for them. So then we can reverse that and make a flood map from that flow. So the water model actually uses a slightly different HydroFabric than the FIM because they have 2 different purposes. We both need catchments, but the FIM is where to put the water surface elevation in that catchment, and the water model is to define how that rainfall turns into flow into the river segments in your area. And the biggest part of HydroFabric is maintaining computational efficiency. There's 3.3 million river miles. In fact, you can go to the next slide, Jeff, kind of summarizes all the facts about this. 3.3 million river miles mapped, and you can see we do superconus, which is basically areas that flow into conus rivers. We are working on oconus. We have a portion of Alaska. I saw a few Alaska people on here. You are not forgotten. We do have South Central Alaska mapped and modeled and creating FIM Live today. We are working on expanding to the Yukon Territory. We also do mapping for Hawaii. We do mapping for Puerto Rico, Virgin Islands, and next up on our list is Guam and American Samoa. All territories to be covered by flood and inundation maps. Hydrofabric is the most important part, and that is also the limiting factor. So getting data in the Yukon Territory obviously is difficult. But you can see how many hydro locations, those are the key areas where we want flow measurements. 280,000 flow hydrographs are generated for our short range forecast we generate every hour. For our mid-range forecast, we generate every 6 hours. So we can go to the next slide, Jeff. Well, that's the hydrofabric. So let's now go into generating the map libraries. We have two methods that we're currently using. Height above nearest drainage is our go-to for everywhere. Everywhere we can make height above nearest drainage. Ripple or 1D RAS is where we take the FEMA BLE models, the MIP program, we grab all the RAS 1D models that we can, and we generate mapping through a process we call Ripple. And we'll talk a little bit more about that. We can go to the next slide there, Jeff, and we'll kind of walk through the hand model first, because this is kind of what everyone has, no matter where you are. We start with the digital elevation model. As we told you, we work with the 3DEP and NHD Plus as our streamline network. That is very important because the streamline is where we hydro condition everything to. We hydro condition to the hand method. The hand means height above nearest drainage. That nearest drainage is that flow line at the base of this all. And you can kind of see that in 2 where we decide where the flow lines are. Once you have the flow line, you can determine which cells drain into that flow line. When you do that, all you do is start creating a relative elevation model, AKA if the flow line point is 0, what is the bank full? Is it 2 feet? Is it 1 foot? Is it 4 feet? 4.5 feet? Where is that? And then you just keep working your way up the DEM from those drainage points. And then when that value gets triggered, AKA we've got something that is 2 feet above the relative elevation of the flow line, we will inundate everything at 2 feet. You stitch that together at a 30 by 30 meter grid cells, and we create a flood inundation map. We stitch that together for the entire nation, and we get flood inundation maps for the entire nation. Go to the next slide, Jeff. To generate the relationship of the flow coming out of the water model, or the flow coming from the river forecast center, or the flow coming basically from anywhere, we use internal synthetic rating curves. So we take the Manning's equation and we basically turn the flow to figure out how can we turn the wetted perimeter and hydraulic radius into a water surface elevation. That process is where we have the most flexibility to calibrate, adjust, and verify that our mapping is working well. So everything runs through the Manning's equation, and it seemed simplistic to start and not that difficult until you start realizing that slope is one of the most sensitive parameters, and your Manning's number, as it should be representing one thing, is actually a really big calibration and tuning method. So we adjust a lot of these parameters. We originally, and we'll talk about the evolution, adjust these parameters for the entire nation. So we would just make a small tweak here and there across the entire nation and basically improve all of the mapping. Well, we've done that probably to the point of exhaustion, and now we're starting to move regionally. Places like the Ohio River Valley, which are very difficult with the lock and dam system, we have to change different parameters to get it to work in that system. Florida, always a nightmare. Very flat, very limited terrain to hold the water in, and our DEM, which has obviously got a resolution problem that Florida can't capture. We really got to fine tune the slope there so we don't blow things out of control. So we are starting to get to the honing in of our flood mapping to a regional basis. Go to the next slide there, Jeff. This is just an example of NRP FIM, which we call retrospective probabilistic FIM. So if we were to run the FIM across the entire nation, you get a map as we stitch it together like this. So each one of those red boxes is a catchment. Each one of those red boxes has its own synthetic rating curve, has its own flood map. Those flood maps technically do not talk to each other, aka when we move water from one catchment red area, red box, to the next red box, we can't spill water from one to the other. We can with RAS, but with hand we can't. So as you see here, you know, it has a look of seamlessness, but if you really zoom in close, some of those red lines limit where the flood map can go. We have been making advances to allow our flood mapping to expand beyond these catchment boundaries so that it can spread a little further out. RAS is not limited by these catchment boundaries, but by its own cross-sectional extents. So map libraries are getting better as we keep moving forward to advance this tech. You can see there in the southwest part of Fayetteville, there's a kind of a catchment boundary, what we talk about, that is kind of rubbing up right against that red line. That's what we don't want to see. We want the water to be able to expand as far as it can, as it needs to display the FIM. Next slide. Okay. Now for ripple or RAS FIM modeling, basically what you see in this animation is what it's doing is we take a water model reach, an extent, and we run the flows up and down that reach to inundate that catchment. The great part about ripple, which makes it different than just using flat RAS, is we can run a portion of the downstream to kind of give it a backwater effect. So you're able to run flows upstream, you're able to run multiple flows downstream, so that you can kind of judge based off of HEC-RAS how the backwater may impact the flow. This is really important when you get close to junctions, and that's why we're happy with the ripple mapping we are getting. Doesn't work everywhere for every 1D map, but when we can get it to work for a lot of these areas, we have 250,000 miles mapped now with ripple. I'm sorry, it's not because I live in Texas. We are heavily biased into Texas with their BLE models and availability, but we did expand to Northeast, and a lot of areas in the Ohio River Valley are getting ripple now as we continue this evolution. The more 1D maps we have available, the more we can actually implement into our mapping libraries. We feel that this is the most accurate method. It is more accurate than hand in most places, just because of its resolution and its availability to discretize the model at cross sections instead of just lump sum like at a catchment. Next slide there, Jeff. So this is just a map that kind of shows you here. This is close to, this is Texas. The mix of what our mapping looks like and how we actually have to utilize knowledge to pick a model for each water model segment, each one of those red little catchments we showed earlier. So the yellow here is where we actually have res, blue is where you have hand, and you can kind of see how they mix together. So we're selecting the best map where we have available. Main stems have a lot more RAS than the tributaries. Tributaries are basically hand, but that's actually better because hand does really well in the headwaters, and especially in high terrain headwaters where the ripple, because of the HEC-RAS, needs some flow to really get going, works better in the main stems. We do have 1D running. We are in the testing of running 2D RAS, and we hope by this time next year we start implementing 2D RAS. So if you're looking at this going, we don't do 1D RAS anymore, that is okay. We understand that's a little bit of the past and people are moving towards 2D. We're really excited to get 2D RAS up and running here soon. Next slide there, Jeff. Let's move to the pipeline. This is the, okay, we've now made the libraries everywhere, right? We've made the libraries. We go ahead and store them in an Amazon S3 bucket. We keep them there ready to be used when needed. So what we do in the HydroViz visualization pipeline is the model actually gets initiated at 12Z. This is for example. So 12Z or 6 in the morning for my time, model gets initiated. That's when the balloons get launched and all the information goes into, say, the GFS model, the Global Forecast System model. Well, it takes a few hours for that to run. So we actually get the output of that around maybe 18Z, or sorry, 15Z, 14Z. That goes into the water model and runs. And that runs for flows across the entire nation. That takes another 2 to 3 hours. So then it comes into our pipeline ready to run around 1820Z. For a short range model, something like internally we use some high resolution models just to view them, they run in about an hour. And the RFC, the River Forecast Center, when they put out a forecast, we have those ready in about 20 minutes. So that's the time frame of when we get the data. We then go in and we make the synthetic rating curve, we look up the synthetic rating curve, the flow from those models, and find the associated water surface elevation from the rating curve. We go and we grab the map points for each reach. And if you're a GIS person, we vectorize everything. We do not use rasters because it's faster to grab the polygon vectors. We stitch together all the vectors and create a general overall FIM map. And then we publish the service using Esri GIS Enterprise System. And we publish them into our service. It takes about 8 minutes for a mid-range to run, 5 minutes for the shorter ranges or the RFC to run. So it's not much for our pipeline to run. It just takes a while for us to get the data into our system. And then we update the service and it publishes over and can be seen on the NWS page. We can go to the next slide there, Jeff. Lastly, we go to the dissemination phase, which means what I was talking about. We publish these services. We currently publish publicly 3 types of service. The analysis, and Jeff will show you and probably go over these, which is using near-time modeled observed gauges where we have them, USGS gauges. We assimilate to USGS gauges. If we don't have a USGS gauge, like you're upstream of it, we use the MRMS rainfall running through the water model to use the analysis. There is no forecasted rainfall in the analysis. This is rain on the ground into a flood map. It's working actually today, and hopefully Jeff will show you here in Texas, Central Texas, where we have some good rain going on. The second forecast we make is the mid-range forecast. It's using the rainfall forcing, or the forecasted rainfall from the national blend of models, 5-day run. So it runs 5 days worth of forecasted rainfall, and it produces a maximum flow from that 5-day forecast. If everything is receding, the maximum flow will be observed and it would look just like analysis. But if in the forecast we have a higher flow expected, that's the map that it grabs. That's the flow that it uses, puts in the rating curve, grabs that map. And then lastly, the RFC. We get a forecast from the River Forecast Center. We put that into the water model and replace the flow and run that so that we can grab the maps at all the points downstream. It only works at and downstream of river forecast points. It is available about 15 minutes after they put their forecasts out. And that's the 3 publicly available disseminated. Next slide, Jeff. So let's talk a little bit of how we've evolved, because this will give you a kind of a glimpse behind the curtain of how much work we've evolved from. I'm just going to highlight a few of these, but this is available in the slide deck in case you want to go through all the updates we've gone through from version 3 to now. We're just released version 6 in October. One of the big things in version 4 was varying Manning's end, where in the Manning's in the in channel, we were using one value as the out of channel. Now we changed it to the in channel has a value of 0.06 and the outside the channel was 0.12. Then that improved our synthetic rating curves for a lot of sites. The other thing we did is we actually run our FIM processing twice. So we'll run it once for the main stem where we grow the catchment size so that the water can spread really far. We're not limited by these really tiny catchments on the Mississippi River or Ohio River or Colorado River. We can spread a lot farther. And then we run it again for the tributaries where we do have the smaller catchments and we want to capture that. So that was a big advancement in 4 is running our FIM processing power twice. Moving along, our first version of RAS was released in 4.4. We actually reduced our static FIMs down to 1 foot intervals. And then we did one of the biggest things we did in version 4.4 was we started using updated bathymetry. So we used observed bathymetry on the Ohio River in Pittsburgh. We kept on flooding. It used to be Heinz Field. The Pittsburgh Steelers Stadium. Hope they lose this week. Go Bears! But we kept on flooding their stadium, and so we found that if we added bathymetry, which we had from the Army Corps of Engineers, it really improved our rating curve, and we were able to keep that stadium dry when it wasn't flooding. And we actually got accurate to the stair step, which was exactly what we're shooting for. So then in version 5, we added bridges. That was the big thing we've added. So in the hand method, we burnt bridges in our post-processing. After we developed the flood map, water surface elevation, if that water surface elevation was below the bridge deck height or an estimated bridge deck height, we would then take the bridge out. And this would help you guys identify if a bridge is actually flooded or not. This was a big advancement. It kind of set us apart from all the other advancements that people were making, is being able to know if a bridge is flooded or not. Before, the water would just look like it crossed all the bridges. Now we put over 750,000 bridges into our modeling. It's not all of them. In fact, today, if you look out in West Texas, there's a lot of bridges that aren't identified out there. But we did get the majority of bridges, particularly in urban areas. And then version 6, to kind of say, we started doing regional enhancements for the first time, and we also figured out a way to allow water to cross catchments. Basically, we were using the hand method. So if you think of a large, long catchment in Kansas, right at the top of the catchment, it had to drain all the way down to the bottom to reach its height above nearest drainage. But the river was right alongside of it. So we were able to change the algorithm for water to find its closest path to the river instead of finding its closest path to the nearest, the downstream drainage of that catchment. A little confusing, but it allowed us to be able to cross catchments and allow water to move to its most likely destination into the river instead of the forced destination due to hydrofabric cutting out weird catchment sizes. We also added a lot of those RAS modeling in recently. There is one catch with the RAS modeling. We did not and have not yet burnt in the bridges. So it's a little tricky right now if you look for a bridge and if it's inundated or not, because next update we will be burning the bridges back into the RAS modeling. It was just very tricky to do because this was a collaboration of 3 different contractors all working together at once. So future updates keeps us employed. Next slide there, Jeff. And I want to give you guys a glimpse into the future before I pass it over to Jeff. We'll give you a more practical simulation of how to use FIM in your area. But some of the things that we're looking for, and I will caveat this, and there's 800 people, please don't all contact your congressman to demand these updates, but these are the things that are on our queue to do. Directly in response to what happened in Kerr, Texas, we are trying to make a rapidly updating flood mapping. You saw the delay in a short range model, an hour, and then hour and 20 minutes, and then plus another 8 minutes to get processed, plus dissemination time, we're an hour and a half to hour, 40 minutes. There are certain parts of this country that an hour and 40 minutes is too long. Rapidly updating flood mapping is something that's on the curve, and we are testing a new model to run that could update every 30 minutes to every 10 minutes, but we'll probably update it every 30 minutes to begin with and hopefully reduce it to 10. That would give those people a fighting chance. We have a lot of internal assessing tools that we use for decision support. We can see internally structures that may go underwater. We can see internally bridges that may go underwater or are threatened. And we turn that into a message that we put out in our warnings, in our watches, in our messages online. We're looking to add roadways this year, and that's a big advancement to us, and that's the #1 cause of death from flooding is people driving through roadways that shouldn't be there. If we can add that and be able to label in our messaging, this road's going underwater, this road's going underwater, I think that'll be a huge advancement. Depth is the #1 thing everyone asks for. It's also one of the most complicated things we could do. We're looking into its feasibility in terms of cost, because we will have to switch everything from a vector to a raster. If you're a GIS person, basically means instead of a nice, easy to draw polygon, we'll have to make a grid. and that's expensive. So we're working in that. One of the biggest updates we are going to do, and I think is the most exciting, is we are going to do what we call likelihood. It's code for probabilistic, giving you probabilities of flooding instead of just yes, it's flooding, no, it's flooding. We're hoping to have that experimental out in this year, so our offices can test it out, give us some feedback before we make it a publicly facing product of likelihood FIM is what we're calling it. We're going to expand, obviously, our modeling. I talked about some of that. 2D RAS and floodplain is another option we're looking at to be able to better discretize the flattest areas of the country. If you're sitting in Nebraska, parts of Missouri, Iowa. Iowa has very great, very good modeling, but we're trying to utilize all the Midwest and desert Southwest into improving these areas with better models because the hand method just doesn't capture the flat terrain as well. We are getting new benchmark data, and this is kind of a plug from you guys, is that when you're in your floodplain and it gets flooded, if there's any verification stats or anything, we will use it. We will help calibrate our models and our mapping based on impacts. Improve routing techniques. We want a mobile and offline capability. So we're working on that. It's in development. But when a flood hits, it takes out a lot of towers. It's really difficult when you're trying to get into a floodplain that's devastated to get all the service and everything you need. It would be great if you could just have your flood map offline on your phone and you could walk in there and not have to worry about bandwidth or having service, because if you get it when you're in service and go to off service, it'll still be there stuck in your cache. And of course, something in the future for our coastal friends is total water level modeling, something that'll be greatly improved. Since hand doesn't work well in the coastline because it's too flat, this is a new model that's coming out within, hopefully in the next couple of years. We'll be testing it here, probably in the spring. Jeff, I think that's all I have today. I think I'm turning it over to you to take it from here. Oh, no.
I think you got one more. Yep.
This is an example of what that probabilistic FIM was. Colors not like this. We're not going to rainbow everybody's desktops like this. This is a dramatic feature, but it shows the likelihood of inundation. And the reason why I wanted to show this so much, because then this is a much more actionable item, I think, for the people that are here. You see the blue hatched line. That's kind of what the deterministic would say versus what the probabilistic would say. You can see that, the outer parts are, 10% chance of happening. So maybe the structure gets impacted or not, but it puts you guys in the driver's seat of what's your threshold of comfort for deciding to close a road or deciding to tell a structure that they need to prepare. This is the problem with this is that this is not a FEMA map. This is not a FEMA flood insurance map. This is different. This is dynamic. This updates. It uses the physics of the region. So it's meant to be used in a flood fight. And if you get this in forecast mode, the big call is separate yourself from the FEMA maps. Put yourself in the driver's seat of this is the possibility of this rainfall creating this flooding. And I think that's going to be a huge advantage for you guys over just having the blue line, having the option of being like, well, I'm comfortable up to 50%. After that, I would say we have to do something. So hopefully this is more actionable intelligence for you in the future. Now I'll turn it over to you, Jeff. Please don't surprise me with another slide.
Alrighty, thank you, Derek. So Derek talked about the development and the continued progress of the flood inundation mapping program within the National Weather Service. And now I'm going to talk about how the National Weather Service is using the flood inundation mapping to transform flood prediction, and even more importantly, flood impacts prediction, adhering to the National Weather Service's mandate of the protection of life and property. And the National Weather Service is ushering in a new era of water forecast services. And this is supported by a long-standing legacy models, but also our new and improving national water model that Derek was talking about. So we're really excited for the future ahead, and being able to provide not only more forecasts, but more rivers and streams, but better forecasts and better information. So to appreciate where we're at today and what the future holds in the development of these new transformational water services, let's just take a step back and look where the National Weather Service has come from as far as services and information. And as many of you well know, it wasn't that long ago that all that was delivered was a text forecast disseminated out through the weather wire for a 3 to 5 day forecast of river height, with only maybe the expected peak crest for each day. And then in the 1990s, we got into the internet revolution and came along, and our services went uh, from text over the weather wire to graphics shared out on websites. And we expanded some of this to ensemble forecasts as well with this graphical capability. And then in the 2000s, we started to make some efforts in what everybody wanted, and that was flood inundation mapping. And though we did do it, it was limited, very limited. Only a few select communities ever saw inundation mapping, roughly 200 across the country. However, the requests, they kept coming from decision makers, first responders. They understood and appreciated a forecast of how high a river was going to get, but really what they really wanted and really needed to know what that forecast was going to do and what impacts were going to be affected. Knowing what is going to be flooded and what is not going to be flooded, that was what was most important for these decision makers. And so finally, that is where we're at. After decades of asking for it from decision makers throughout my career, it's here, and it is the future. And we're really just beginning, as Derek said. Flood inundation mapping across the country, basically 3 million river miles from the summit to the sea. And so here's the National Weather Service's rollout plan. This has been ongoing for the last several years. So the first 10%, we started in East Texas and up there in the Northeast, where we had some of those Weather Service field offices that had seen some experience using FIM prior to the rollout. That's where we started. That familiarity helped get the FIM off the ground, the flood inundation mappings off the ground. In the fall of 2024, we went over to 30% of the nation's population, which included the Ohio and Mississippi valleys, the Pacific Northwest, and even Puerto Rico. And then last fall, we expanded to 60% of the nation's population, including California and the Plains, parts of the Southeast, as well as Hawaii and even parts of Alaska there. You can see the remaining parts of the country are still coming, with the eastern coastal areas going last, as this will likely be the most complicated with that interaction between the coast and the freshwater flooding, which we often call the total water level or coupled modeling. So by next September 2026, we'll have the rollout complete and be serving 100% of the United States population. And so you might say, what does it mean as far as providing flood inundation services to the U.S. population? And what it really means is we're providing these complementary forecast flood inundation mapping services to the public through our websites and data services. And I'll show you that toward the end of the presentation with a hands-on. But also it means our field offices, our National Weather Service forecast offices, having these maps that they can share and use in their operational decision support services, whether that be through their briefings during events or other means of direct communication. So what services are being made operational and available to the public right now? Well, there's basically 4 right now. Derek talked about them a little. 3 are what we call dynamic, meaning they change with a changing forecast or observation in real time. They're dependent on the actual ongoing event that is going on. Another is what we call static flood inundation mapping services. And 2 of these services, the latest analysis in the water model 5-day max flood inundation map, use the national water model The third, called the RFC 5-day max flood inundation map, uses the RFC, the official RFC forecasts, by replacing the forecast flows of the national water model with that actual official RFC forecast that many of you probably are familiar with. And you can find these on the National Water Prediction Service, and we'll show that to you with the hands-on as an available service right now. And this, for 60% of the country, has it available. And that National Water Prediction Services, that website is available at water.noaa.gov. So what are these services? The first one I'm going to talk about is this analysis flood inundation map, which is the inundation map that is not actually a forecast, but rather shows what could be happening at the current time or the assimilated time. It uses USGS gauges, flow gauges, as well as the latest observed rainfall or precipitation to simulate those flows and inundation at that particular analysis time. And this is updated every hour, and it shows potentially what the water extent of the rivers and streams, with one caveat. The flood maps, the caveat being the flood maps don't show everywhere, but they just those rivers and streams that meet what we call a high water or high water threshold. And not to get into too much in depth about the high water threshold, but is based sort of on a predetermined flow threshold for every reach within the national water model that Derek was talking about. And these high flow thresholds, they're generally in the 1.5 to 2 year return flow for most reaches, just to give you a perspective. But again, this is the latest analysis flood inundation map and available within the National Water Prediction Service website. And I'll do a live demo at the end showing that service. Now, the National Water Model Max Flood Inundation Map is the forecast flood inundation map service. It uses the forecast precipitation and temperature from, as Derek was saying, the National Blend of Models meteorological model. This is the model that most of the forecasters use at the field offices for the actual weather forecast coming out of the National Weather Service. And this FIM actually goes over the next 5 days to show the maximum inundation extent over the next 5 days. And it does this for all the streams and reaches in the 60% FIM areas. This service is available 4 times a day in line with the availability of that meteorological model data. And then the final dynamic service is the River Forecast Center Flood Inundation Map. This again takes the River Forecast Center's forecast and replaces the National Water Model forecast flows with the RFC forecast. So this flood inundation map is only available for the RFC forecast locations, and will show it basically shows the FIM at the gauge location and just downstream. So the idea here is to be able to see what the inundation looks like based on the official River Forecast Center forecast at the gauge location. This is probably our most popular and one of our most used services, and it puts the flood map to the forecast hydrograph. And then there is the fourth FIM available, and this is the static flood inundation mapping libraries at select River Forecast Center locations. These are not driven by a forecast, but they rather serve as a set of layers that show the inundation at each flood category level. You probably are familiar with these flood category levels. You can see each flood category. It shows the extent and the color it has. So at gauge locations along rivers and streams, the National Weather Service field offices set these levels of minor, moderate, major, and these are based on impacts at those locations. They actually go out and oftentimes survey to find these levels. So again, those maps will show what would be flooded at those critical defined levels. The public can go and see what might be inundated at these levels at minor flooding versus maybe moderate flooding. And the maps are generally at the gauge site and extend downstream 5 miles at most locations. Um, you can see the orange showing where the water extent might be if the water reached a minor flood, or where it could go if, in the red there for moderate flood levels. And you have the option of changing the map background too, and we'll show this so you can see the underlying satellite imagery of buildings and roads, which is a nice feature of the website. So how are we using flood maps as a decision support service with our partners in our field operations? It is important to note we look and use the FIM at a neighborhood level. The baseline DEM resolution, again, as Derek pointed out, is 10 meters. So we're not looking at particular homes or buildings or zeroing in on certain spots, but rather neighborhood level, looking at the general communities and seeing what is going to stay dry and what is going to potentially get wet. Now, of course, it's not always exact, and development and accuracy has improved drastically, as Derek was pointing out from the beginning. And this is going to continue for years to come. From better accounting for bridges to bathymetry, improvements are being made, and we're just in the beginning, as Derek attested to. So how does impact decision support services look right now for the Weather Service and the utility of this flood inundation mapping? Well, we have public services like the website, the NWPS website already out there, but most of the true value has been our National Weather Service field offices using the flood inundation maps in their baseline and targeted decision support. This from adding flood inundation maps into their event baseline briefings to targeting flood inundation maps to a location as being asked about. This really does go to the heart of the flood inundation map and its use in terms of the impact decision support services that the Weather Service is using right now. And then there is the integrated impact decision support services where we're using flood inundation mapping alongside the partner sharing and showing the information. Say, for example, if we were at an emergency operations center. And, this can really help our decision support partners with operations such as planning and positioning assets, to strategy where we're in the midst of the event and keeping situational awareness, to tactical where actions are being actually taken, such as evacuations and high water rescues. And the flood maps can help present some clarity to that situation. And so the key here is the flood inundation map. It goes beyond the forecast hydrograph, showing the potential impacts and presenting actionable intelligence. And so we see the forecast for major flooding on the top left there, and then the associated flood inundation map forecast showing the water extent covering that area where you see the pizza restaurant. And then the bottom left, we see the actual result. Now, here's an example that went out to our partners for that specific event in Connecticut with the National Weather Service hydrologist actually annotating on the graphic the confidence, basically annotating the confidence in certain areas having issues with inundation. You see the forecaster at the office included the forecast hydrograph and the map showing the predicted water extent, as well as some key points as far as the time of issuance and the crest height. Again, the forecaster has some added annotations to help guide the partner or the user. And over time, with continued improvements, we hope some of these annotations, like bridges not expected to be impacted, you see there on the map, hopefully some of those will go away with the improvements Derek's group is making. And another and a more recent example from Hurricane Helene in Asheville, North Carolina, based on the River Forecast Center official forecast. This shows the forecast graphic, the key messages and the timing, and finally the map. So you can see how valuable a map is versus just a forecast hydrograph. Both important, but the map shows what might be impacted and also what areas might not be impacted. The map presents that improved intelligence that our partners can take action on. And you can see this added intelligence is making a difference. A recent example here in Indiana, some of the feedback from our weather forecast office in Indianapolis, highlighting their use and their success of using flood inundation mapping in their operations. We got a lot of positive feedback from their partners. This is one of several. Another one, finally, another example. We all know the tragic story there in Kerr, Texas. But downstream at Georgetown, this was actually where we saw flood inundation map have a success story where the flood inundation map was used and changed the response pattern and likely saved lives in that county downstream. So these examples they show the why we have these new flood inundation mapping services and the efforts that Derek's group is putting toward it, and why really we're so passionate about them within the National Weather Service. We're excited about what more the future can hold as far as protection of life and property and the use of these services. And so let me show you exactly what we're talking about as far as these tools. One being the National Water Prediction Service. And let's go ahead and do a hands-on here. And we don't have a lot going on today, but we do have a little bit. You can see it's pretty quiet across the country today. So if you're wondering how to get to this site, so this is the National Water Prediction Service, and you can get it to it by going to water.noaa.gov, or you can type in at a Google or NWPS space NWS, and that'll bring up the site as well. So this is what would be initially would be brought up. And let me go ahead and show you. There's a shortcut. It's got a lot of options here on the right side menu. But one shortcut to the flood inundation mapping services is if you go to more water information and you click on flood inundation mapping, if you go to this FIM guidance, this will actually bring you to the map that is geared toward the flood inundation mapping services. And it might take a while to, a few seconds to load up here. And I'll highlight a few things that have showed up here, one being the red line. And as you can tell, that sort of aligns with the map that I showed earlier in the slideshow. This is the line. This is basically the line that shows where the flood inundation mapping services are available at our 60% of the U.S. population level. Again, it would be all this area as well as California. And by next September, we'll fill in the Great Lakes, the Rockies, and parts of the eastern coastal part of the United States. So this is what we call the 60% FIM zone inside here. And as I was saying, what you're seeing here let me just highlight one other thing. You can see also the coastal emission zone. This is where future work will take place. This is where we were talking about the total water level, the compound flooding. The flood inundation mapping could still show up in these areas. It's still available. However, we always say to use caution in these areas for now. But the plan is to continue to have that. Now let's go ahead. Let's show you a couple of things. Let's go ahead and show you where we have our flood inundation mapping services. And we're going to start here in eastern Nebraska. Notice on the legend here, we have the National Water Model max forecast. So this is going to be the max flood inundation mapping forecast. And we have some other features here. One being the flow magnitude parameter, and it basically highlights all the streams or reaches that the National Water Model is showing where we're exceeding what we talked about earlier, that high flow threshold. So anywhere where these streams are lighting up in these colors, this is where we're going to have our flood inundation mapping available to us as a user. And you can notice very quiet across the country today, unfortunately. We do have some streams and rivers out here across the plains that are showing some rivers and streams meeting that high flow threshold or beyond, and then a sporadic isolated ones across other parts of the available area. But we're going to go ahead and zoom in to these areas, and we're going to zoom into eastern Nebraska. And I'll show you what this looks like. As we zoom in, you'll notice the flood inundation mapping coming to light here. And we're going to give it a second because I don't have the fastest of internet here at the office, but now we can start to see it here. And again, most of it is in bank, but we do see the available flood inundation mapping. And then nice couple of other features that we have available is you can change the actual opacity of the inundation map here to see the underlying map. And if you wanted, for example, to change the underlying map, or the base map, we would call it, we can come up here and change it. And in this case, we'll go ahead and change it to the satellite image. And we'll give it a second here. Hopefully that'll pop up. But the satellite image will give us that satellite imagery where we can see the underlying infrastructure, buildings, roads, streets beyond this layer here. Let's try it one more time. And it might take a while, and we can see, I'll go over to a couple of the other features here. Let's go down and so that's the water model, National Water Model forecast. And again, that'll show up. Maybe if I zoom out here, it'll be more apt to that. Again, the flood inundation mapping for the National Water Model will be available anywhere where you see these colored rivers and streams that fall along with the flow magnitude here being exceeding the high flow threshold. It's trying, folks. Afternoon internet woes, I guess. Let's go here and let's look at the RFC max forecast, and we're going to go down into Texas this time. And now the RFC max forecast is going to give us, we actually got a minor flood forecast. This is an update from just an hour ago. And we've got an update minor flood forecast for the Trinity River at Dallas, Texas. And let's see if the flood inundation map is available. So they've had some heavy rain in that area during the overnight and this morning. And again, you can see here, now we see the available flood inundation map. And again, I can change the opacity and see the underlying. And it's unfortunate that we're not getting that base map to change. But again, you can see the potential impacts here along the river, as well as the map does highlight other features such as levees, embankments, and you can turn and toggle off that levee information. And again, the River Forecast Center FIM, River Forecast Flood Inundation Mapping, it'll be available wherever there's a forecast above this action stage level. So when we zoom out here, we'll see these two areas, this area down here on the San Saba River, San Saba River. But those will all have flood inundation maps for the gauge location and downstream. And that is based on the official River Forecast Center forecast. And then finally, let's look at the analysis. And again, this is showing you, as I would call this forecast, this service is sort of the what's happening right now service. And let's go over to Menard, Texas, because they had some heavy rain this morning. And I'm actually going to use the search button here to zoom into the Menard area. And again, they've got an action stage forecast out. But we can see the analysis here for the past hour. Again, you can see the flood inundation mapping, and we can change that opacity. Now the underlying base map, you can see it does have the structures here, and it doesn't appear there's any risk to structures, but maybe the golf course here. And this is where you put that forecast to actionable intelligence. This is the benefit of the flood inundation maps. And so that is really some of the biggest uses. We also have the static fin maps. And if you want to know where all those are, again, those are actually in this area, flood inundation mapping. If you wanted to see what locations have the static flood mapping, where you can see the mapping of the minor, moderate, major. We could go to any one of these. Let's go to the Susquehanna River. And I'll show you where this is actually available. You scroll down, again, here's where the hydrograph is. But again, these are not based on the real-time forecast. Let me see if I can activate. It's a little slow right now, unfortunately. But what should be coming up is a map here. And I think it's more my internet than the actual website service. But you can see here, you can actually click off and on the different flood category levels. So if you just want to see the moderate and the 1 foot moderate levels, let's go to another location to see if another location will come up. And I'm going to refresh this sucker. And I apologize, it's just being a little slow with this. But usually you'd be able to see this, and again, go use this site, go practice yourself, see where the services are available in your area. It would be under this more water information, flood inundation mapping. I will warn you, I think over the next several months, we may be changing this menu within the National Water Prediction Service to make it a little bit more user-friendly, but all the same information and sub-menus will be here, including the flood inundation mapping menu. We might actually make it a little bit more visible. But all that information is right here. And this is actually the partner FIM locations is actually the initial flood maps that the Weather Service did back in the early 2000s. That's the 200 locations I was talking about. So that is a little bit of insight using the National Water Prediction Service and our flood inundation mapping services that are available. There are a couple of other tools that are also available for maybe a little bit more technical users. One of them is the National Weather Service GIS viewer. This viewer is all-encompassing, has got weather and water information. But if you type in NWS GIS viewer into a Google, it'll bring up the link. That's probably the easiest way to get to it. And then for water information, again, it's got all kinds of information within this viewer. But if you go to water here, we click on water. This has got many of the same flood inundation mapping services, but beyond that, it actually has some of the National Water Model data services as well. And I think my internet is just acting a little bit slow right now, but here we go. Here we go. So again, it's very much the same information that's available in National Water Prediction Service, but maybe a little bit more robust as far as being able to see some of the added National Water Model services. One of the other nice features about this tool is you actually can get the data service links. And for you out there that are more GIS savvy and you know about the data services, and I'll show you our REST service link here, and Derek will probably talk a little bit more about that. But these REST service links are available within this tool with the different services here, not only flood inundation mapping, but also some National Water Model services. So I would just suggest go to this tool, hunt around. The way to get to the water side, like I told you, is to go in here and use this change site, click on water, go in there and take a look what's available. There's a lot of information, a lot of a good data services in here for water and for other things as well. And that's the National Weather Service GIS viewer. And then finally, because I want to leave plenty of time for questions, finally our REST services that are available. These are what I'm talking about. This is basically the same links that you see here. If I click on here, go to data source, the actual data service here that you can bring into maybe ArcGIS Online or ArcGIS Pro or your GIS tool of favorite GIS tool. But the data services are all here. And Derek, do you want to mention it? Talk about these at all?
Sure. We actually had two separate questions that I've been furiously answering that address this specifically. Maps.water.noaa.gov. You can go straight there. Any of those services you can bring into your own ArcGIS Online tools. You can bring them into OpenStreetMap. You can bring them into QGIS. They're open source and available. They will, if you put them into ArcGIS Online, I know for sure they will update automatically. So if you make a tool out of them, they will continue to update with the latest information that you can utilize. So yeah, pretty simple to use. If you click on one, Jeff, any one of them, they may have sublayers built into them. Like you can see, this one has a 3-day and a 10-day and a 10-day. So there are sublayers for each one of those. And if you actually go back to services there, Jeff, just to give people a little navigation, up one more if you can.
Services, yeah.
There are more than just National Water Model. If you click on RFC, for example, you can see the RFC products there. And if you go back and you click the FIM-LIBs, we apologize for our naming convention, but the FIM-LIBs are all our static maps where you can grab static mapping for certain locations. So yeah, anything, if you are a GIS person or have a GIS team that you can access, get them this and they can make you some fun tools and toys with our services.
And if you have any questions on what the services are, we have this the nomenclature here is sort of coded, but you can see as Derek was pointing out, the MRF is mid-range forecast and the SRF is the short-range forecast. But yeah, a lot more services here than are publicly available, even though these are also publicly available. A lot more services that are within reach here in the data service. Yeah, let's see. I think that's all we had. Let's see. Where did my I think that's all we had as far as and let me bring this back up here. And again, these are the 3 services and the URLs for those services. And that's all Derek and I had. There's our email. So if you have any questions, you could email us both.
All right. Jeff, Derek, thank you so much. So we do have some time for questions. If you have a question and you haven't submitted in the Q&A area of the Zoom interface here, go ahead and do that. Derek has been pulling double duty. Derek, you presented and you've answered like well over a dozen questions. So if you are listening and you asked a question earlier, go ahead and check back in that Q&A area, and you probably have an answer in writing. So thanks very much for doing that. A couple reminders, and then we'll see if we have a couple more questions before we wrap up. But just so everyone knows, once again, this is eligible for continuing education. We'll be issuing certificates of attendance. This session has been recorded. Obviously, there's some follow-up in terms of where to find these tools and resources and so forth. I'll be distributing all of that to you via an email. My goal is to do that before Thanksgiving, so please look out for that, and just try to be a little bit patient. I'm going to hopefully try to get it to you all middle of next week. Kieran's asking for the web addresses for the tools. If you can, just flip back to that. Thank you very much. Let's see what else we have. Sarah's asking if the question and answers are going to be shared. Yes, so I'll be creating kind of a PDF document of the question and answer queue that we've had here. So yes, the answers in writing that'll be shared and distributed with the group. So good question. Thank you for that. Okay, I'm going to try to catch up on some of these questions. Bear with me a moment. Okay. Gregory is asking for state and local partners looking to enhance FIM output or minimize uncertainty of results for our particular area of operations. Who should we contact to collaborate on identifying what local data or analysis would have the biggest benefit to the FIM for particular areas?
That's
So again,
it's a great question. And you can reach out to either Jeff or me. We're pretty open, but we are actually just as we speak, we are moving into what we consider regional enhancements, and working with state agencies is actually on our annual work plan this year to get more data and actually share and collaborate before the flood maps are published publicly, so that you guys can have more input if you so wish in your regional mapping and suggestions on better sources of data like LIDAR, DEM, better sources of high water marks or verification that we could utilize. So yeah. And the next question is the model skill of information at gauge locations. We have that internally, but we're looking into one tool that kind of summarizes everything you guys are kind of suggesting, which is like, is there a way I can look locally and maybe move a slider to see how the FIM would change as flow would increase if there's an increase of flooding and all that? And then can I get the statistics of that area? This is all in a development with a website with one of our Cairo partners. Cairo is our research arm that we reach out to a consortium of universities that work on a bunch of different things. And this is one of the key things they're coming across with. So I think we can hopefully answer that question, a lot of your questions, with a tool like that kind of lets you dig in when it's not flooding. That's I think that's the biggest question I think everybody wants to be able to do. What can I see when it's a clear sky day and I can look into some of the impacts that may happen?
Just a follow up on the FIM use, I just wanted to say too, we're the Weather Service and the Weather Service field offices, they're not in tunnel vision with just using our FIMs. They're when we do these FIM reviews, and they're doing their FIM reviews during an event, they're looking at the FEMA flood hazard layers oftentimes as a guardrail, or even some of the state FIMs that are available out there. We train them to try to be aware of other FIMs that are available from local and state governments, as well as other federal partners. Now, they won't necessarily use those oftentimes in briefings because, we can't really brief off some other agencies. But, we oftentimes might guide the user to maybe take a look at those or use them as guardrails for our own flood inundation maps.
Okay, wonderful. Thanks very much. So Drew has a question, and I apologize. You may have touched on this earlier, but if so, I might have missed it. It seems we have to have a forecasted weather event to see any of this in our community if covered. But what about if you want to look at this model to forecast potential flood-prone areas? There
Yeah, I
doesn't seem
think
to be a map unless rain is actually in the forecast.
no, it's a good question, and Jeff went over a lot of material, and it could have been missed. The CAT FIM, the categorical FIM.
Mhm.
We apologize for calling it CAT FIM, realizing that it only makes sense to us, but there is what we call categorical FIM available for gauge sites, and when you go to a gauge site, you'll be able to bring up for probably about 70% of the nation a a flood map that's relative. There we go. Yeah, I can see it right there. Relative to these categories, they're available at all times. You can look at them at any time, and based on whether it's a major flood or minor flood or moderate flood, you can then see the mapping. It's not available everywhere. We apologize for that. We're working on a version that will be available everywhere. I think I answered the question earlier, is that we have a big discrepancy about FEMA flood insurance and us putting out mapping just for your use. So until we have the higher ups agree on a format that makes that not confusing for everyone, we can't put mapping out everywhere just yet. So I think they'll be able to iron that out sometime in the future. But as we are right now, this is the only static maps that you'll be able to look at any time.
Mm-hmm. Mm-hmm. Okay, great. Thank you very much for that.
Yeah, good question.
Definitely. All right, last question in the queue for now, and we'll see. I'm not sure. So Chris is wondering if you can discuss the communication strategy with state and local communities on sharing this information and how to best utilize it during a flood event or for planning purposes. So I guess I don't know, Chris, if the thrust of your question is, is NWS communicating this during a rainfall event to states and locals? I'm not sure. But guys, do you have any insight into that?
Yeah, this is a fantastic question and maybe a great one to wrap up on, because
Yeah.
this is the crux of everything, is that we can make all of this, but if it's not utilized, what's the point? And that's really where Jeff and I came into our jobs. We came from operations where we struggled to get our message out there during a flood because a lot of people didn't understand hydrographs or the impacts of a hydrograph. And it's tough. It's just a graph. How are you supposed to understand a graph? And how it's going to impact an entire community. Putting it into a map then makes that impact real, right? Puts it on a map. You can see what structures are being underwater. The communication plan was then for the local office to communicate to the state operations center or WFOs, which are our forecast offices, our local forecast office, communicating to the local or regionally emergency manager about the potential impacts using the flood maps. For 60% of the nation, as Jeff pointed out, the flood maps are public and anybody can go in there and see them. It works better if our office communicates the impacts they're seeing on the flood map and the confidence they have in the flood map. And that's actually what I just heard about 2 cubicles over them doing here in Texas today. And that really is the communication platform, is we want our offices to support their messaging with a flood map. Not all offices are the same. And I see people from all over the country. Well, the 10% offices here in Texas and over in Northeast Pennsylvania, where else, Jeff, is within the first 10%? New York. Trying to think of all the states that were involved. They have more of a experience than say the 30 or 60% offices. So it isn't, yeah, see the green, the forest green areas have more of an advantage over the teal and the yellow. And then right now, next week or two, we're going to start training those teal offices across much of the country. So the phased training means you're going to get phased responses in the communication plan. Here in Texas, it's actually really good. Interesting enough, and this is odd, Florida has really good communication of flood mapping because one of our best people is sitting in the Florida Emergency Operations Center. We have great communication with the state of New York. Recent events in Indiana, Ohio, Kentucky, Pennsylvania, we have really good communication with them. But you start getting outside of there, where we do get still major flood events, and we do not have a real good communication platform set up. So I just wanted to be honest that this is a learning curve to get these maps over the hump of innovation of this is a cool tool, new toy to actually utilized every flood event. And to put in an example, that Georgetown event that Jeff pointed out, shared it with the EM. They loved it. They utilized it to close roads, 0 casualties. About 10 counties to the south, that was Kerr. Happened too fast, couldn't get flood maps out to the people. We all know what happened. So we know flood maps help. It's just getting that in the communication pipeline during a very severe flood event is still a challenge. So great question.
Yeah, great. Excellent answer. Thank you, Derek. Okay, we don't have any more questions. We'll wrap there a couple minutes early. To our presenters, thank you so much for your time and sharing this with us. It was really interesting. I know I personally learned a lot too. And to the nearly 700 of you who've hung out with us for an hour and a half, thanks for taking time out of your schedules to join us. We do these quarterly, so we'll be sending you an email that for the next one when the details of that are lined up. In the meantime, I'll be following up with you soon via email with all the promised follow-up from the event today. Thanks again, everybody. Have a great rest of your week. Take care.